Okay, so it's 9 o'clock. We're going to go ahead and get started. Thanks for everybody for coming on. We have over 100 participants. This is probably the largest webinar I've ever done. I'm sad that I can't see all of you, but I'm glad that we're able to interact during these tough times. So thank you for coming out. My name is Derek Ross. I'm a solutions engineer. I'm a lead solutions engineer in North America for BrowserStack. I've been doing DevOps and test automation, and I've been a technical product owner at a couple Fortune 500 companies like GE Aviation and T-Mobile. I've been building pipelines and messing around with code for quite a few years now. I look forward to talking to you today about some of the learnings that we are going to be able to show you around CI/CD pipelines and continuous testing at scale. Remember, if you have any questions, please fill out the poll, and I will answer those at the end. And if you have any questions that don't get answered, feel free to DM me and the LinkedIn or the Twitter handle that I will share at the end of this presentation. Just to give you a little heads up about BrowserStack, if you don't know, we're about a 9-year-old company. We were started in a coffee shop by Nikul and Ritesh, our two founders. Since then, we have 15 data centers open. We have 400 plus employees. We have 3 offices across the globe in San Francisco, Dublin, and not Dubai, but Mumbai. And because of that, we're able to really service customers across every industry across the globe. We take care of customers who are leaders in each of the industries that you see here. We're in finance and insurance, technology, media and publishing, and government and defense, and something else that's not on here is medical. So all of the toughest data restrictions and confidentiality are able to test on us and to make sure that they can take care of their customers. We help power the internet by providing infrastructure and testing results to some of the most popular and used open source projects on the market. So jQuery, Angular, Ember, Gatsby, just to name a few, test on us. And the reason they do that is because we have 2,000 plus browsers, devices, and OSs available to our customers to test what's being represented by your customer base. So if your customer base is testing across 1,000 different combos, and going through your customer flows, using those devices, we have the representation for you to use those. Executing at scale is a very difficult thing when you're doing end-to-end test automation. We have 2 million registered users on our platform that are executing 72 billion Selenium commands a year. They're doing it from 135 different countries, and we can't even keep our slides up to date. We're pushing data centers out so fast. We had 10 when I started here, and now we're at 15 distributed data centers that you can access all with one username and password. And those data centers really help. Having that distribution really helps with your test automation latency to make sure that you have the fastest scalable pipelines that you could possibly have. We're also we also provide testing solutions for the world's largest cloud providers. So the people that you rely on for infrastructure, Amazon, Google, Microsoft, Oracle, they rely on us for test infrastructure. And I think that's a big testament to the quality product that we're offering to the market. The products that we are offering are in 4 categories at the moment. They're Automate, App Automate, Live, and App Live. The main differences between those 4 is 2 are for web products, so Automate and Live. 1 is for automating your web products and on desktop or mobile. Live is for testing those with a manual session. We can open those up, and I'll be showing those to you today. App Automate is around automating native applications, so your iOS and Android applications, and you can run XUI, Espresso, or Appium for those. And then we have App Live, which is our live testing platform for your native applications. Now let's get into the bread and butter of the presentation today. Today we're going to be talking about scaling your CI/CD pipelines, how to use those pipelines to really gain efficiencies out of your test automation. And here's the agenda for today. So we're going to talk a little bit about what a DevOps team is, in my opinion. We're going to talk about where we start. What's the foundation for getting getting a good pipeline up and running in your enterprise? We're going to talk a little bit about artifact management. And we're going to talk about why you shouldn't automate the world and how to do all this from CI/CD using Jenkins. So I think it's really important to always start out with what I think a DevOps team is. And this is what I teach most of my customers. So a little bit of my background, I told you guys that I'm a technologist. I've been in DevOps for a while. I've been a technical product owner for pipelines. Prior to that, though, I was in the military. I was in the Army for 8 years. And during that time, I was a Green Beret. And one thing I learned being a Green Beret is how to organize a team to accomplish a mission without needing external help. So we were very independent as a unit. So some of the lessons I learned from the ODA as far as how a DevOps team should be, and ODA is an operational detachment alpha, it's a team, is that when you're planning your mission, when you're planning on going somewhere, when you're planning on going to a foreign country and you have something to do, you have a mission to accomplish. What is everything I need to accomplish? So on a team, we have 12 guys, that core team. You have a medic, you have an engineer who can build things. You have a communication specialist who can run our networks and help us with our radios. We have intelligence officers and we have leaders. All of that is combined into one team so we can go anywhere and do any mission, and we're self-contained. If we have a medical incident, the medic's there. If we have a communications issue, we have someone who's an expert and can set up those communications. So everything is self-contained. Well, sometimes we're taking equipment or we're doing something where we don't have that skill set on the team. And so maybe we're taking trucks and we need mechanics, or we're going to need someone to cook for us. So we need cooks. And so we go find those people and we make them organic to the team. And that team grows from 12 to 15 to 20 to whatever it needs to be to accomplish that mission. And that's the way I assemble DevOps teams. So when I plan a DevOps initiative, or I'm going to transform a organization from waterfall to DevOps, I find out, what does this team need to deliver? What do they need to deliver what they're asking? And how do we go get all of those resources and skills onto one team so we can handle it all from one place and keep decision-making at the lowest levels? So characteristics of a DevOps team is it's self-sufficient and it's self-contained. Think startup culture. A brand new company with 5 employees, 10 employees, they don't have the money, time, or energy to really invest in large manual testing efforts, into doing all these validations and checks. So they have to build automation to make sure that they can grow and scale at the speed of their competitors who've been doing this for years, or just have a lot more money and time and resources. They're cross-functional. So just because you're on a team and you are a developer doesn't mean that you can't write a test. And just because you're an SDET who doesn't typically write application code doesn't mean you can't participate in writing a Jenkins file for a pipeline. So being able to move across the stack is highly important in a DevOps team these days. Decision-making power needs to be invested within the team. So when a team has to constantly go outside the team for infrastructure, for permission, for budget, for anything that they need to accomplish their goals and to deliver software, that's going to slow them down and it's going to create bottlenecks. So we need to invest as much as we can into a team so they can have decision-making power. That team needs to be mission-focused. We want to try to avoid scope creep at all costs. So we want that team to be focused on building what they build and knowing why they build what they build. So are we building something customer-facing? Are we taking care of internal customers who drive revenue somehow? Understand why you're building what you build. So when people ask to insert different things or different projects or these little shadow IT projects, you have a reason to say, I don't want to do those things. These teams have to be highly focused. So technically and process-wise, where do we start to support all of these DevOps initiatives? What does it even mean to be a DevOps team? Does it mean that we have all these tools? One thing I like to say is you can go to Home Depot, you can buy all the nicest DeWalt saws and tools and drills and have a big old F-350 truck, and you can come home and you can have all that in the back of your truck. But if you don't have any knowledge or skills on how to use those to build a home, then you're not a contractor, you're not a carpenter, you're not a mason, you're not any of those things. So just because your company goes out and buys GitHub and buys Jenkins and buys Artifactory and buys automated deployment tools, if they don't use those in a way that actually supports DevOps processes, all you're doing is dressing up a waterfall process. So let's talk about what actually needs to happen to support DevOps processes. In my experience building pipelines, I have found that the most important foundational thing that we can do to get a team ready to receive DevOps processes is to have a good, solid, standardized branching strategy. So I say work towards some version of trunk-based development, but my personal opinion is that if you've never done anything, you should start with Git flow. And Git flow is what I have documented in this drawing to the right. It's well documented. It's supported by common Git tools like Atlassian SourceTree, which is free. And I'm going to demo that for you, and something that you could go get if you wanted. And it provides a stable base to choose a more streamlined branching model. So if you wanted to get rid of some of these branches, all you would have to do, let's say if you wanted to do trunk-based development, instead of having develop and master, you would get rid of develop, and then this would be master. And just to explain a little bit of this diagram, each of these dots is a commit. So this is me pushing code. And so this will be a git push, and you'll see that in my demo in a little bit. And we have multiple feature branches happening at the same time. Any branch that has these dotted lines is a short-lived branch. That means once the branch is done being worked on and that feature is complete, we're gonna do a pull request. That's these dots up here. And anything that says PR, those pull requests are gonna get reviewed, and we're gonna merge that code. We're gonna delete the old branch, and then we're gonna have this new branch that has, or this branch that has this new bit of code that we created. And these are pull requests. And at some point, we're gonna decide that we wanna make a release out of that pull request, or any of the code that was there behind it. So we're gonna pull that up to a release branch. We're gonna do a few commits, make sure it's ready, and then we're gonna push that to master and develop. And this is gonna go to production. And this will go to QA or a develop environment, whatever we want. But what's really important about this is that we have these branches to separate code, to maintain a good versioning strategy, and we're gonna set ourselves up for an event-based pipeline. And most importantly, whether these are named feature branches or this is gonna be the flamingo branches and these are gonna be the hippopotamus branches, it doesn't matter what these are named. What really matters is that these are standardized across the business. So me as the CIO or a release engineer, I should be able to go into any team or any repo. And as a new engineer on that team, I can just show up and I know that master is where the production code is. And so I'm gonna pull off of the latest master and I'm gonna have the latest code. If I wanna pull the latest development, I'm gonna go to the develop branch, pull the latest commit, and I will have the latest working development code because I know that through CI it's been built. So that's some of the things that we can accomplish by standardizing this across the whole business. What that allows us to do is set up CI as code. So we all know about CI tools, Jenkins, Travis CI, Azure DevOps. There's a bunch of different tools out there. It's really becoming a commoditized market. But what I really care about when picking a CI tool and a CI process is that we have the ability to code out our CI processes, which I will be demoing for you. So I want to create common libraries for build and release workflows. So if you're familiar with Jenkins, Jenkins has the idea of shared libraries. If you wanted to, you could have shared libraries in any language that you wanted. You could script them out in Node.js, in Groovy, in Java, in Go. You could use whatever language, but I think it's important to have common code libraries that handle common builds that become very portable that can go to any environment you want. I have a theory that 70% of your CI code should be code that you wrote in scripts. 20% should be configuration in a CI file, and 10% should be configuration in your actual CI tool. And that makes your code the most portable that you could possibly make it. I want you to utilize CI code templates like the Travis YAML, the Jenkins files, or you could even Dockerize your build. So you could have Docker files, or you could have Docker compose files that actually structure out multiple steps of your pipeline, which is really kind of almost the holy grail of a fully automated CI pipeline. And then it's impossible to do this without a standardized branching strategy. So if I want to scale my Jenkins files that are set up as templates to support this, then I'm not going to be able to do that if all of them are different. And I'm going to quickly show you a little bit of code right now that's going to show you what I mean. This is a Jenkins file. this Jenkins file has different steps. So I can say, I want to check out code here. I want to build my code here. I want to run unit test here. I want to run my end-to-end test code here. And then I want to have a product owner review. And so what's really cool though, is I could say, if this branch is release or hotfix, I want to do this step. I could say, if this branch is release, or if this branch starts with pull PR dash, that's a pull request, then I want you to do ABC steps. So by having a good standardized pipeline, this allows us to write code that will use those branching strategies as events. Artifact management. So artifact management is going to fit into that branching strategy. So what do we deliver? So if we go to General Motors or we go to Ford, what is their artifact that they're delivering? They're delivering a car to our driveway, a truck to our driveway. If we go to the kitchen store, or we go to Walmart, or we go to the grocery store and we buy a pot, that's the artifact that that company is delivering to our home. And our home is what production is. So what are we delivering? The artifact that we're delivering is usually going to be a front end, or it's going to be a native app. So it could be an IPA file. It could be an APK file for Android, or it could just be a zip file full of static files and JavaScript that's getting shipped to a production environment. But what we want to do is we want to tell the story that that particular version of that artifact went through. So did it have unit test run? Did it have security scans run? Did it have my end-to-end test run? Did it go through a code review? What are all the steps that it takes to get an idea from my product owner's head to production? And what are all the steps in between? And what was the story that that artifact traveled through all of those steps? So we want to use an artifact repository. We want to build the artifact early and then deploy that through the environments and test it along the way and record that story. We want to version those artifacts using something like semantic versioning. So it could be 1.0.0 or 1.1.1 or 2.0.0. We want to track quality and processes by this artifact version. So who looked at 2.0.0? Did the product owner review it? Did the release engineer review it? Did the developer look at it? Did we run tests on it? Did it go through all the environments? Is this ready to go? What's that story? Tools available for this are Artifactory, Docker Hub, internally hosted file systems. You can do this however you want. Again, it's all about standardizing it and keeping a good process. Deployment automation. So we got to have our environments deployed. One of the biggest hindrances to actually getting a test automation initiative off the ground is having environments that aren't ready. So I deploy my UI and my microservices that support that UI are down or they're not reliable. And so now I can deploy whatever features I want to my staging environment and I can write all the tests I want, and they could be the highest quality tests that I could possibly write. But if I don't have a quality environment up and running at all times that's ready to test, those aren't really useful. I want to automate all infrastructure management tasks. So if I have to add firewall rules or access management, or I have to configure the OS in a certain way so that certain files are accessible by certain users, I want to do all of that with automation. That needs to be laid down in a CI job before I can access it as quickly as possible. Some tools available for this are Docker, Chef, Puppet, Kubernetes, Terraform. That list goes on and on. It's a very commoditized market. Again, use what works best for you and standardize on it and keep doing it. Finally, there's test automation. And so once we get that good foundation, we get that nice assembly line of code, and we can actually start using our test automation to trust our pipeline. Test automation is what allows us to trust our pipelines to deploy automatically through the environments and hopefully ultimately to production. And the funny thing is we find this very hard, and we've been thinking about this for years as a software industry on how to best do this. But when I worked at GE Aviation, I saw that the manufacturing industry and manufacturing engineers and aeronautical engineers and electrical engineers, they've been using these processes for years. And so they know that if they write good processes and set up very good assembly lines to build all of the small pieces that go into this engine that's on the top picture, that they can test things in isolation. So they can build a fan blade, one of the big blades, and then they can take it and they can bend it. They can do whatever they want. They can write test to test on it in isolation before it's a part of this bigger solution. And then once it gets into this big thing, it's part of a component. It's part of the engine component. And now it can be tested more fully. And then at the very end, we do our functional test and we fly the engine on the full aircraft. That's the end-to-end test. That's the last thing we're going to do prior to production. So we should be thinking about our CI/CD pipelines this way. So how can I test my application in the smallest component possible, as fast as possible, while I have it fully exposed and it's not attached and dependent to all these other things? That's where our unit test comes in. That's where our API test levels comes in, our functional API test. Our user test, our UI test, should be atomic isolated flows, and we should be able to run those concurrently. But in order to really take advantage of all of these, we need to have that solid foundational pipeline that had all of those aspects that I just talked about prior to this test automation slide. Don't automate the world. Humans are still way smarter than computers. And I've used a lot of aviation stuff here. One thing I was into when I was a kid was fighter planes. I loved fighter jets. And if you follow aviation, from the beginning of aviation, it used to be prop planes and there were no computers and it was all very mechanical, and you flew and the pilot had to think about everything. They had to think about wind speed, direction, altitude, fuel. They had to think about all of these things. And over the years, we've added gauges and computers that start solving some of these problems for the pilot. But guess what? We still have pilots. Even though we do have drones today, for some of the hardest flying, we have a human pilot. So we have human pilots in the airlines, we have human pilots in our militaries, because they can think and adapt to situations much better, and they can catch things that we don't write into our automation. And so this is why I say don't automate all of your software processes. Do what the pilots do. Get as much instrumentation and get as much information into the person's hands that has to make the decisions, and make it so they can make those decisions as fast as possible in the most reliable and risk-free or risk-reduced manner that they possibly can. You want to weigh the cost of automation versus other options. Every time you have an automation initiative, make sure that you're weighing those costs. Is it going to cost me more to automate this than it would just to go ahead and do it? Conduct human sanity checks. This should be done prior to production if the team is not mature. I'm going to show you some skills and ways to do that in your CI pipeline, where you can insert human sanity checks but still have an automated pipeline. It should be conducted, these steps should be conducted by functional owners of the latest features shipped into your pipeline. So functional business champions, product owners, and then release engineers who manage the entire scope of the application to let you have any warnings that they might see from their experiences managing your stack. Over automation can kill your delivery velocity. So I've been in projects when I first started in test automation and I was a little bit quieter and less opinionated than I am today. I've had managers say, we're gonna do 800 test cases or 1,000 test cases this quarter. That really got in the way of delivering any quality automation or quality test code because we were focused on the wrong thing. So really focusing on the right deliverables, having that good foundation and understanding what you wanna automate and why are all key aspects. And I think one overarching thing that I would really like you to take away from this presentation is that you could have all these tools, but they really don't matter. It's the underlying processes and thoughts that really drive the success of a DevOps transformation. So these process transformations are not easy, I'm sure, as everybody here knows. They require executive buy-in, they require money, and those budgets need to be accessible to the people who are on the execution team. And I'm not going to go too deep into methods because I want this to be a technical session. So we're going to jump into the demo soon. But we could, if you have questions around any of these processes or structures that can be used to help drive transformations, please feel free to reach out to us. We talk with CIOs down all the time about how to do this and how to change things outside of your test automation to support your DevOps processes. Team structures is another one. We alluded to this at the beginning of the presentation with the way Special Forces operational detachments are created and maintained. They're self-contained and they contain every skill needed to complete the product delivery. and push decision-making power to the lowest levels when possible. The decisions should be, the majority of decisions should be made at the product team level. And we do that by giving handrails. So one thing that I experienced as a Green Beret is I would get a mission. I would be told, do this. Here's your left limit. Don't do anything too crazy over here. And here's your right limit. Don't do anything too crazy over here. Within that framework, within those principles, here's your authority to make decisions. Here's money to get your job done. And here's resources. You can do the same thing with your DevOps teams, is give them handrails. This is what we wanted delivered. Here's a few thousand, 10, 15,000, whatever budget that you can execute with. We'll give you more later. And then you let that team go and you let that team make decisions. The lower the decision-making power is within the teams, the more likely a DevOps initiative is to succeed. Standardization is key. And these are the places that I find create the most value to standardize on. Your single project management tool, a single source control management tool and branching strategy like GitHub or Bitbucket, single artifact versioning strategy and a single place to keep those, one reporting mechanism that allows the journey of a build, including the design phase, and it follows that from idea to production. It provides it to all the different roles, whether it be the developer, the product owner, the release engineer, or even the CIO. And standardize wherever the cost of not doing so outweighs the cost of customization. So just forcing everyone to have a Windows laptop or a Macintosh laptop or an Apple laptop solve any kind of large business problems? No, not really. In my personal opinion, let your developers develop on whatever platform they want. If they want a Linux box, give them a Linux box. Let them be comfortable. But if they're like, well, I like Gitflow and the rest of the company is doing trunk-based development, so I'm going to do Gitflow, that's not cool. That hurts the rest of the enterprise. So standardize where it makes sense and where it helps everybody. But also let your developers and let your people do what they want to do and let them be comfortable, because that's going to help them stay motivated, stay on the team longer, and create an environment where they actually want to be productive. And I think that's a really good point to add to this that I don't have in the slides here, is that not only do these processes help support you having good delivery processes and getting features in front of your customers faster, but it creates a better environment for developers to work in. So as a developer, I don't want to go work at a place that doesn't have these processes and tools, because it makes my life more monotonous and harder. Where there are businesses that I have worked with who have built out these tools and actually built out a better workforce because of it. So there's added benefits that come to this besides just delivering software. All right, so we're going to jump into the demo now. It's going to get, we're not going to have any more slides. We're going to start doing some technical pieces. If you have any questions as I go through this, please feel free to fire them off into the Q&A, and I'm going to leave some time here at the end. So this will be about a 10 to 15 minute demo. The very first thing I want to show you in this flow is not even going to have a CI tool involved. When we want to execute tests locally on our environment because we've hosted a site, that's a very common use case. But I also consider it part of the pipeline. So being able to test locally and test before you ship up to a pipeline, I think is important. So one thing that I like to do is set up environments or set up test automation so that as suites so that my developers can test on their local machines. So we can see here that I have a site hosted on my local host at localhost 7225. And I have two views here. This is an Angular project. It has two very simple views. And my mandate right now is to add a demo view. And so I want to test that out. So we're going to go ahead and we're going to test this. So we're going to run locally and we're going to go in my package.json. I'm using WebDriver IO. And in my JavaScript, in my package.json, I have set some different commands. So I have WebDriver IO, BrowserStack local. I have WebDriver IO, BrowserStack develop. I'm going to do a branching strategy and I'm going to test by that branching strategy. So I have some code here. And I'm going to go ahead and I'm going to test against my local environment, and I'm going to use this local test. And I have this configuration file, and in that configuration file, I'm going to point it at some test files. So I have my test written here. I'm going to run it on BrowserStack. So I'm going to use my BrowserStack username and my BrowserStack access key to run this on BrowserStack. And I'm going to point it at BrowserStack by using hub.browserstack.com. And what I want to do is I want to test those two views, and I want to test them in different browsers. So I'm going to set those browsers here, and I'm going to do Firefox, and I'm going to do Chrome, and I'm going to do a mobile test on an iPhone. So I'm going to do npm run, and I'm going to do BrowserStack local. And so I can test a site that's hosted on my local environment. Here is where I have the site started. I have my server.js running, and that's what's hosting my site. In this command line, I started a binary called BrowserStack local. And what that does is create a tunnel, a connection from my local host to BrowserStack, because BrowserStack's out on the internet, on the public internet. It's going to come over the public, it's going to come through that tunnel, and it's going to come onto my machine and able to access local host environment. So we're going to start that test. It says my local testing is not connected, so let me go ahead and restart that. All I have to do is point at the binary, and then I need to give it my access key. Now that is started. I'm going to rerun those tests. So we can see here that it's navigating to local host, and it's navigating through my site. And if I wanted to look at that, I can go to BrowserStack. And I can see that just a few seconds ago, I had some tests run on my local host. And this test failed, and I want to know why it failed, so I can quickly go to a reason. And it can't get text on this element. And then when I see this yellow, I know that it was unable to find the element, and it was unable to find this element. I can click here, and I can see exactly what the screen looked like during that moment. And I can play through and watch the whole test execute. And because I had the build tag set, it aggregated all of those into one build. So I can come to this screen and I can see it by build. And if I have a bunch of builds and I don't want to search for it, I can just go in, type in my name since I know I just executed something. And now I can see there's my last build, and it's executing those tests, and now it's executing on mobile. So now I want to start developing. So I want to add a new view. So what I'm going to do is we're going to create a demo view. So I have some code set up on my desktop. So I have these files here. I'm going to go ahead and move those. And I'm going to put those into my current repository. So we can see I just added this new view, the HTML. And so I'm saying this demo is going to pass. I'm going to add a test for this. So this is going to be a unit test. Excuse me, this is the unit test. And then I'm going to have the JavaScript that's going to interact with the controller. And then I'm going to go to the index.html. And I'm going to go ahead and add that demo to my view. And then I'll be able to go here and you'll see when we go to localhost here, my demo is there. And so now I have my controllers hitting this. I can run that. And now what I'm going to do is I'm going to go ahead and run npm test. And what that's going to do is it's going to run my unit test. So it's going to run those unit tests. It's starting my karma conf. And in BrowserStack, we can actually see whoop, can't click. On BrowserStack, we can actually see that this text is executing, and so we can do cross-browser testing on our Karma.js test. And so that ran, or that's running. And now those are completed, and I'm confident with that. Now I can rerun my end-to-end test. Those are running, and now I can go to BrowserStack. I can see those are back up. And without ever setting up anything on my machine, without creating infrastructure, without setting drivers, I was able to create these, run these tests, and never have to waste any of my time doing anything except for writing code. And I can quickly consume all of these results and go about my job. And now this is passing. And so I can go in and I can see that it's passing. I have my demos and I'm accessing all of this on localhost. So we're going to go ahead. We're going to do a git checkout. We're going to push this up to the remote repository. That just went up. And because I have a good branching strategy, I can go to my repository. I can see that this feature SOL demo was created. So I can see I have feature SOL demo. I can see I have develop. I can see I have master. I have a GitHub webhook set up. So I can go into the webhooks. I can see that I have this webhook set up for my local Jenkins environment. And what that does is every time there's a push that happens, it lets my environment know what's happening. I can go to Jenkins and I can see, because I have that Jenkins file, it created a job for me with that branch name. And it's running those steps that I have laid out in that file. So in that Jenkins file, all of these correspond. So I'm doing a checkout and I can see what branch I checked out because I printed that to the console. So I can see here after it checked out, the working branch is feature SOL demo. Then we're going to build that code using our BrowserStack credentials. We're going to run our Karma.js test. So I can see here that my Karma.js test ran. I have a step for executing end-to-end tests here. I have a JUnit reporter step here. And then my product owner review. This is where I was talking about having a human input. So in the file, I have it set for an input and it has product owner review. And that's what shows up here. I can put whatever custom message I wanted here. And then I can also limit this to, so I could say the release engineer, the product owner, those are the only two people who could hit proceed. Once we hit proceed, that completes. And so now I know that this job has passed. I'm happy with that. I can go to Jenkins, or I'm sorry, I can go to GitHub. And in GitHub, since I'm happy with that and I want that demo, that view demo branch to go to my QA, I'm going to go ahead and I'm going to do a pull request. So I'm going to set the base as develop. And that feature, oops, sorry, the base is going to be. And I think actually, here's a good place to demo what I was going to show you with source tree. So this can get a little confusing sometimes. And the reason that I like GitFlow is because we can use a tool like source tree to actually manage this. So now that I see I have this feature, Soul Demo, I actually want to finish this feature. So I'm actually going to push this to the remote. Oh, come on. Merge it. Let's get the merge going. Excuse me for my fat fingering. All right, so now we can go to show all checks. We can see that the check looks good. And what it's going to do, it's going to base this off of my last job. So I'm going to click the details page. Now I can go quickly see that feature SOL demo. It passed. I'm confident now. And now I can make a decision to go ahead and merge that. Now, if I wanted to release that, all I need to do is use something like source tree. And so I'm going to go ahead and reset this. So I'm going to delete this branch that I just merged. That no longer exists. So I can see here, it updated. Now it knows about feature soul demo, that's gone. It knows that master is about just release some code, receive some code, and so to develop. I can see what the commit was. And now I can go to my environments, which I'm using Heroku. And I can go to any of these environments. And the demo guys aren't being happy with me. Here we go. And while those are going, I'll show you how to actually set up. So we're going to go ahead and sync this with our remote. And we're going to push this update. And I apologize, I couldn't get that to deploy to the staging. I think I had a mistake, but just for sake of time, I just wanted to show you that we can run those tests, and then now we are confident, and then that automatic ship after we click proceed allowed this to trigger and push the deployment. I'll debug that later, but demo guys did not play with me nice today. So that's the demo as far as the pipeline. So now I want to show you the different abilities to consume different tests in the browser. So not only were we able to consume those desktop tests of the Karma test that ran, and then our end-to-end test that ran, but also we can run these on apps. So if we want to run these on a full native app, the only difference that we're going to add to the pipeline is in that beginning step, we're going to add a push using our BrowserStack CLI. And so what I'm going to show you here is we can actually use our BrowserStack CLI here to upload an app. And so we can just use our command line, and I have this set up as a package JSON, but I'm going to go ahead and grab this and show it to you directly from the command line. So if we wanted to upload an app at the beginning, we're going to upload this Wikipedia sample. There we go. And so now you can see here that we're using this command, BrowserStack app automate apps upload -p Wikipedia sample. It's uploading the app to BrowserStack. And what that's going to do is it's going to give us a hash. So it's going to return this hash. And instead of giving it just a URL, what we're going to do is in our conf file, we're going to provide the hash that gets provided to us. So we can set that as an environment variable in our CI tool, or we could just provide it directly, explicitly in our file. You can see here, it returned that app URL. Automation in the app automate dashboard looks exactly the same. Whether you're using Espresso, Appium, XCUI, the results look the same as what we just looked at on our dashboard with Selenium. We get the video, screenshot, logs. And just so you can see what the experience will look like when we upload that Wikipedia app, it's going to open a device. We have this Galaxy S20. It's going to start the device. It's going to download the app directly on the device, install it, and start it. And we could manually interact with this, or we could have used automation to actually navigate through a flow. So that's the end of the demo. I just want to let you guys know that there's going to be an episode 4 of Selenium and BrowserStack at scale with David Burns. He's going to talk a little bit more about your test hygiene and how to scale your actual test. It'll be a little bit less of the pipeline discussion and more of the test automation discussion. David Burns is a core committer to the Selenium project. Very good resource. I highly recommend that you attend that session. And now we're going to quickly go through any questions. We have about 10 minutes of Q&A. So I'm going to go through any of the voting and we'll start answering some questions. Let's find my Zoom.
Derek, sorry to interrupt, but we are actually out of time. This is a 50-minute webinar, not a 60-minute webinar.
Oh, got it. I'm sorry. I thought we had 10 more minutes from here.
So what we'll do is, I'm sorry to interrupt, but what we'll do is we have a few questions and we will be reaching out to you individually with answers. So please expect to see emails from Derek or one of us sometime early next week, Monday or Tuesday max.
I have a question about sending the presentation. Yes, I can send the presentation. That will become also, yes, we will go through all these questions that I have here. Sorry, I see that somebody wanted to make it a bit bigger. There was some like around recording. So there's just a few questions around the actual product itself. So if there were any issues with the actual presentation, I apologize. The slides will come out. There will be a video. It was recorded. As far as any of the technical questions, I'll make sure to get those out. And then also, if you have any questions that were not asked, my information is right here. So on Twitter, I'm at DevOps Derek Ross. On LinkedIn, I'm also DevOps Derek Ross. Feel free to reach out to me, have a discussion there. And if you're a customer, we can set up a future meeting, or if you're not a customer, we can set up a future meeting to go over any product. I will share the screen so you can see my contact. I apologize. There's the contact information. That will also be sent out with any slides. Thank you so much for attending today. It was a pleasure presenting to you.